Hello, my dear students. Welcome to my physics channel in YouTube, that is Pina's Physics Gyan. In today's class, I am giving one concept on circular motions. In my subsequent classes also, I'll keep on giving you concepts on circular motions and many other chapters in physics which will be useful for your board exam as well as entrance exam, that is JEE, NEET, etc. In today's class, where I'll be discussing about concept 1 in circular motions, we have to find minimum velocity of the car. You see the minimum velocity of the car. This is a circular road. You see this is a semicircular road. Road can be also like this. Road can be also like this, as I am showing you in the diagram. Road can also be like this. How this road can be? This road is like this. Suppose. My questions, if a car is at the top of this semicircular road, convex surface, what should be the minimum velocity of the car at the top of this semicircular path so that it leaves contact? That is what the concept 1 is. Today I am going to explain how you will find the minimum velocity. My dear students, not a single body in this universe can rotate in a circular path without centripetal force. And we know formula for centripetal force is, what is formula for centripetal force, my dear students? What is formula for centripetal force? Centripetal force formula is mv square by r. What is m, what is v, what is r? M is the mass of the body moving in a circular path. V is the speed and r is the radius of the circle. You see here r is the radius of circle. Here r is the radius of circle. You see, my dear students, here r is the radius of circle. Okay, my dear students. Although the formula for centripetal force is mv square by r. So what is the centripetal force? Force going towards the center of the circular path. It means we need a centripetal force. We need a centripetal force mv square by r. This is the formula for centripetal force. But although the formula for centripetal force is mv square by r, it has to be provided by some agency. What is that agency which provides necessary centripetal force in order that body moves in a circular path? Again, I am repeating my statement. Without centripetal force, a body cannot rotate in a circular path. Okay, my dear students? Now, we have to find a force which is going toward the center of the circular path. You see, here the car is having mass m, its weight is acting vertically downward, and this surface, semicircular surface at the top, gives a normal reaction on the car which is equal to n. This is the normal reaction. My dear students, when a body leaves contact with any surface, what is the normal reaction? Normal reaction is the force with this force on this body due to surface. That is the normal reaction. If I leave contact with the surface, if a body loses contact with the surface cannot give its reaction force. It means when a body leaves contact with the surface, normal reaction is 0. It means here this semicircular road cannot provide a reaction. Okay, my dear students, now you tell me what is the force which is going toward the center of the circular path, which is equal to mg. Mg is toward the center of the circular path and normal reaction is in the vertically upward direction. So resultant force toward the center of the circular path is, I am writing, resultant force toward center of the circular path is, you see, my dear students, resultant force toward the center of the circular path is, resultant force towards center of the circular path is, towards center of the circular path. Center of the circular path. What is the resultant force, my dear students? I have already explained mg minus n. And this is the force which is toward the center of the circular path. It means this force which is going toward the center of the circular path provides necessary centripetal force. My dear students, although the formula for centripetal force is mv square by r, it has to be provided by some agency. This is the basic fundamental idea which you should have. Okay, my dear students, force toward the center of the circular path is mg minus n, which gives us centripetal force mv square by r. What is m? Mass of the car. What is the normal reaction, my dear students? mg minus mv square by r. Okay, my dear students, when this body leaves contact with this surface, semicircular surface, normal reaction will become 0. Let us put normal reaction equal to 0, which gives us mg minus mv square by r. Now, my dear students, you tell me what is mv square by r, which is equal to mg. M gets cancelled. What is v square? V square is equal to rg. What is the speed v? This equal to root over of rg. So this is the minimum speed. Okay, if the speed is root over of radius of path into acceleration due to gravity, this is the minimum speed at which this car leaves the semicircular path at its topmost point. It means if the speed is greater than equal to root over of gr or rg, you can say rg also, it leaves contact with the semicircular surface at its top. If it is less than this, then it can easily negotiate this circular path, semicircular path at its top. If this speed is more than root over of gr, if the speed, minimum speed at which it leaves contact is root over of rg or root over of gr, if the speed is greater than root over of gr, what will happen? You see, as I have shown you here, it leaves contact, then gradually it comes down as shown, and ultimately it hits the ground. The people inside the car may receive injury due to this. This is the concept 1 in the circular motion, as I had explained. Wait for my second concept of circular motion. Gradually, I will be giving lot of concepts on physics for class 11, class 12 students and students preparing for board exams. Wait for my next class on physics. Till then, bye bye, my dear students.